Alright, another draft science video presentation. So this one will sort of be an overview, just where we're at in this argument and why the counter arguments can't, just they're no, they don't mean anything. You can't use them. They're irrational as counter arguments. Alright, so this guy keeps doing this math thing. Been over it. We already did it. And he has one sentence in here. So you had written the force is equal to the momentum, not the change in the momentum. They're just clearly playing word games now, just silly ones. I'm clearly talking about if you want to know the force that acted on something, we assume that the something's not already previously moving in some direction. And so yes, it's the force is going to equal the change in the momentum. The force is momentum. So clearly that's been the argument. You haven't proven that the force isn't momentum, that this isn't exactly what everything is based on in the known universe is momentum. It's all you need to know. There was nothing wrong with Newton's mechanics again. So let's go over some of this. So it's all this playing gimmicky game. So as far as I can reduce the argument to evade the paradox, and the simple paradox has been illustrated, months ago. Okay, I've been going over this. Is the stupid train analogy just gives it away, right? I mean, you can't say a 5-ton train going 10 miles an hour and then a 10-ton train going 5 miles an hour, okay, that they somehow have any distinction as far as the universe is going to see them as some kind of denting threat or ability to move atoms in the universe. Anything we would call energy, their energies have to be equal. There's no way to make velocity mean more than mass in terms of any interaction that takes place in the universe. The fact is that force equals energy equals momentum. Everything in the universe that you're going to call energy or a force is in fact momentum, is in fact bits of matter that have mass, a number of electrons, a number of protons, a number of photons, a number of stuff moving that has some kind of mass, and it's going to impose a momentum. And that's the entire universe, and that answer was correct in Newton's day, and it remains correct now, and there's nothing wrong with it, no reason to change that understanding. That all you're really doing is saying the matter provides a platform for energy. And so if you have a little bit of matter and you apply a force, you will get a lot of velocity. Okay, and if you have a lot of matter and you apply a force, you'll get a lower velocity, but these two volumes will be equal. I guess I could draw it a little higher because then the volumes will match. Okay, the volume will be the same. That's the momentum. It's your mass times your velocity. So there's no mv squared. It was, again, the history is just terrible, and none of these people in the argument will even acknowledge that the history demonstrates how not to do good science, not how to do good science. And they should at least be willing to admit that the history is ugly as science. Alright, well, I'll pause to erase this. Alright, I'm back. It should be anyway. Forgot to add. Okay, so the paradox is, okay, 5-ton train, okay, going 10, and you got 10-ton train going 5. Okay, now if I crash these two objects, let's say they're going this way, because I got more room over here, into a spring, okay, the simple argument is the both objects will compress the spring exactly the same amount. So the kinetic energy, momentum says these two things are equal. Let's just say they both had 100 joules, and that would be the answer. That's how much energy they have in the universe. The kinetic energy formula, okay, VMV, says that this object has twice as much energy. So this has 200 joules, and this only has 100 joules. All right, and it says it as an overt fact that this is somehow real energy, that you could really collect it, that it really is real, and that these are real numbers in some bizarre perception of their reality. That somehow if you bang into stuff, you will make 200 joules of movement using this object, and you only make 100 joules of movement using this object. You'll only convey, in terms of, I can't even make this argument because it's just so illogical not to recognize that your momentum is what makes other things move. When you bang into something, it's going to be your momentum. It's going to be how fast is your matter going, and how much matter do you have to hit things. So I've used the analogy that you can have one thing going 50 miles an hour, or you can have two things, hit at 25 miles an hour each, and that is the same amount of energy in the universe. The one thing going 50 or the two things going 25, they're going to be able to make the same number of, say, 10 mile an hour things. So they're going to reduce to exactly the same thing if I reduce them to a common thing moving a speed, a common mass moving a common speed of, say, 10 miles an hour. Like I said, they would make the same number of dominoes fall, the same number of things happen. So the paradox is that, yes, I could compress the spring with the 100 joules. It'll compress it the same distance. Then I put the lighter object on the spring, and now I created 200 joules. And that's just can't be in the physical reality, that I can just create free energy by just replacing let heavy things bang into something and store the energy, and then use the energy to launch light things, and I can multiply how much energy I have. All right, so the argument that Piro has provided, the rest of the critics don't seem to be able to provide any argument. His notion of how this is working is that the same spring compression, so I compress the spring a certain amount and then release it, and the lighter object, the 5-ton object, let's say, and same compression in the 10-ton object, he actually says that the 5-ton object only leaves at 1.4 the velocity of the 10. So that somehow this one isn't going to go twice as fast as this one. So the 10 mass object somehow has an advantage now, okay, in the sense that it's going to be able to essentially get more momentum out of the spring. So somehow the spring's momentum is dependent on what mass I put on it. So the spring doesn't have, like, say if it had 200 joules of energy, that's how much we compressed it with. We used 200 joules of force, compressed the spring, stored the 200 joules. He's saying that somehow when I use the lighter object, I can't get that energy out. I can only get 1.4% of the joules out. That somehow the spring loses the energy, that something gets hot or something screws up, and somehow the energy doesn't go into the object. So on its face, it doesn't make any sense, because we know that doesn't, from all our common experience, we know that doesn't happen. We also know a scale reliably is a spring again. We know a scale reliably measures weight. Okay, I mean, if you weigh 50 pounds, the spring compresses a certain amount. If it's 100 pounds, the spring compresses twice as much. All right, so springs work. And there's no evidence that they can't be compressed. I mean, one could argue that if you're going to say they can't expand and produce the energy, then they also can't receive the energy, so it just doesn't make any sense logically. Now, the big thing wrong with this idea, I mean, not only that it's crazy that you'd say that, the 200 joules go into this object, okay, the 10, but somehow only 200, only 100 and, only 100, they're saying 200 in terms of the kinetic energy formula. They're saying they have the same kinetic energy, but in momentum. So let's not use joules, let's just say in momentums. Let's say if this one had 200 momentums, they're saying that this one only has 1.4 percent. That's the wrong way to. Something went. I'm doing something wrong. I just can't think of how I'm messing this up. But anyway, the idea is the velocity. Well, the velocity would be the momentum point, right? So it's like it's 150. Okay, momentums, because I didn't achieve the double the velocity. So I have the mass, but I didn't double the velocity. So therefore, I only have 150 joules. So I have 200 joules here, I only have 150 joules of momentum. So if I was measuring by momentum, not the kinetic energy formula, I only have 150 momentums where I had 200 momentums here. Now the problem with this whole thing is you can just keep increasing this 10. So if I make this 10 20, okay, and then I say the 20 is allowed to collect all the joules in the spring. The spring has 200. Well, if the 20 collects all the joules, then the 10 only can collect 150, and then this is only 100. So I mean, I keep changing this number by just starting with a heavier object. So I can go with 1 ton building, 10 ton building, million ton building, trillion ton building. So as long as I can make a bigger and bigger thing to tie the spring to, I can somehow make this number change. I can make a 5 ton change just by starting with a heavier object and saying, well, that's when I got all the energy. So the heavier the object, the more energy you get out of the spring, right? But you have a maximum amount. You can only get the 200 joules. So the heavier that I make the building, the more and more and more, I'm guaranteed to get that percentage. But if I go half the weight, so if I go with a million ton building, that means the 500,000 ton building is only going to get 150 of the joules. And then I'll go further down, and then further down, and then further down. So 140 actually. 1.4 would be 140. It can't work. It can't be that right answer. It's, yeah, it just can't be. All right, so the thing this comes down to is, what do we need as a piece of evidence to solve the question once and for all? So the simple argument is what I've been looking for, and I really have been looking, and you just can't find it on the internet, which seems really silly. So we just have the same spring compression. We know the spring is pretty good at conveying the momentum. It really doesn't get very hot. It doesn't do anything. It doesn't make crazy noises. Sparks don't fly off of it. So we know that it doesn't waste the energy. It's pretty good at conveying the energy. And so what we just need to do is compress the spring the same amount and launch 2 objects. Now, Stephen Brose sort of did this experiment already, but he did it so badly, right, that nobody's going to take it seriously. And you just launch the objects. Okay, you just take 2 objects, with one has a 10 mass and one has a 5 mass. It doesn't matter. And we'll just see if they have inverse velocities. That is, if the velocity of the 10 mass is 1/2 the velocity of this one. This one has a 1v, this one has a half v. Or we could just make it simple and just make this the 5 velocity and make this the 10 velocities. Now, if that's true, we're already halfway there, right? Because we've already proven springs work. And then the other simple thing to do would be just to collect the energy with another spring. And if they compress the spring the exact same amount, I guess I should write compression at this end, then we can say that we know they have the same energy. That these 2 objects, that it isn't true that there's some special kinetic energy in this one, that this one has 200 joules and this one only has 100 joules of energy. Because the spring will tell us we didn't lose energy anywhere, so that can't be true, right? So then this is over, right? We're done with this stupid argument. Now, I'd say this has already been proven by the Lewin experiment. I demonstrated that you can double the mass or triple the mass on one side, and the other side still gets the same energy. So this one gets 100 joules, 100 joules, 100. Doesn't matter. I can make this 1 mass, I make it 2 masses, I make it 3 masses, and I get the same result going this way. So it's sort of demonstrating that this has nothing to do with any extra kinetic energy. That all there is momentum. Momentum's the right answer. Momentum always was the right answer. There was no reason to change momentum. There was no evidence momentum was broken. It's all just mysticism and voodoo and religious notions that caused the existence of this 1/2 mv squared. Okay, this only exists for silly reasons. It doesn't exist for any legitimate scientific reason. It doesn't exist because there was any deficit in Newton's analysis of motion in the universe. Momentum works. Momentum's a useful word. Momentum's a useful concept. Momentum's a real thing. It's a real scientific, useful thing. It's not some fake thing. It's not some not quite right thing. It's not some plastic thing. It's a real thing, and it works. And kinetic energy attempts to replace it with something better, but there's nothing better about it. There's no problem it solves. There's no situation where momentum doesn't give you a reasonable answer to your question. Now, to some people, it seems impossible, okay, that a dime going 1,000 miles an hour, okay, could possibly have the same energy as 2 liters of water, going 1 mile an hour. Okay, that just seems impossible to them. There's no way those two things have the same energy. But it's just because they're really not thinking about it. They're not thinking about how many dimes you could stick in those 2 kilogram, those 2-liter bottles would hold an insane, literally tens of thousands of dimes fit in that 2 liters. That it's a ton of atoms. The 2 liters has so many more atoms. And so, of course, it takes more energy to move all those atoms. So you're moving so fewer atoms with the energy on one side. So, of course, the energy proportion the line for velocity goes very high. But you have a tiny amount of mass, 0.001, tiny amount. You have 2 here, a full 2. I mean, you've got thousands of difference in the mass. So, of course, the velocity of one goes way up and the velocity of the other is a little tiny thing. But there's not real ability to move matter. Again, if we convert the bullet into, say, electrons moving 50 miles an hour, okay, if we convert the movement into some common thing, they'll both move the same number of electrons, the same amount of speed. They're both made of the same thing. It's just some atoms moving a velocity. Momentum works. It's the right answer. It will take you, say, whatever it is, 2 joules, 2.3 joules, and by my figuring, to shoot the dime or to move the bottle. And if you were in space, that's exactly what you could use to navigate. You could get the same propulsion in a direction, okay, by doing either thing. Okay, you could just do either thing with a little explosion. It would take exactly the same explosion, okay, to make the 2 liters fly off this way and the 0.001 kilograms go this way, at a very high speed, 1,000 miles per hour versus 1 mile per hour. All right, and you get the same thrust, you get the same movement in opposite directions. And that's a fact, and it works. That's Newton's physics. It works, it's complete, it doesn't need augmentation, and it's just a sad truth that, physics wasn't very rigorous. It doesn't test ideas very well. And it accepted this silly, okay, notion that somehow we need this thing that's overtly telling you, that somehow velocity is all so important and mass is meaningless almost. When the mass, the foundation, is just as important as the stuff you're piling on top of the foundation. And there's just no reason there should be this extent of argumentation when they have no one's provided a single piece of physical evidence demonstrating that this isn't true, that somehow this is 2,000, 1,000, it takes 1,000 joules to make the dime move, and it takes 2 joules to make the bottle move. No one's shown any evidence that's true. No one's shown any evidence that the 10-ton train going 5 has less energy than the 5-ton train going 10. That if I collected the energy, I would get less energy. I would like fewer or more light bulbs. There's no evidence that velocity makes more energy. The only evidence is that velocity cheats friction. You can get through friction easier. You can get through gravity easier. You can get through obstacles easier with higher velocity. Higher velocity gives you an advantage in defeating a force, not in meeting the force, not in overcoming the force, but defeating it, avoiding it. So, friction is a force, okay? And the fact is the slow object will have to deal with the force. The fast object evades the force. It doesn't overcome it. It doesn't have more energy. Just like the light thing goes higher in gravity. Why? Well, because it's defeating the force. The force can't act on it because it doesn't have enough mass, so it has less mass. So, of course, the velocity gives it a huge advantage. But when it lands on the ground, it has the same, there's not going to be any difference between the heavy thing, the light thing going fast, okay, and the heavy thing going slower. When they hit the ground, they're going to break just as much crap. So that's where the argument is. So we're just at a point where what simple experiment will prove the case? And obviously I'm not going to invest in it if I can't be sure it's going to mean anything, that there isn't just going to be some other catch they're going to use. So will Piro be satisfied that he's wrong, that the kinetic energy formula is just fallacy, if I can just prove that springs always produce the same momentum, that you can't change how much momentum they produce, and that if I put a lighter object on, it will not leave at 1.4 the velocity, a twice as light object, it'll leave at twice the velocity. If that's proven, okay, will he surrender and concede the kinetic energy formula is irrational? Or is he just going to make some other argument? Is there any other argument to be made? That, I guess, is the point. Is there any other way to evade the obvious paradoxes this silly theory creates? So that's all there is. So, so it's just about engineering a good enough experiment for which everybody can be satisfied. It's just going to, it's like I said, it's not very complicated. And the fact that there is none, with all these air cart experiments, all this stuff that's out there, there is nothing that demonstrates this in the cleanest manner, the manner they need it in. Like I said, there's lots of examples of the different weighted carts and the fact that the same momentum always goes in both directions and that momentum is always conserved. Most all the physics videos say that, but Piro's unconvinced by those videos. So we need one that's even more explicit, that takes care of the last little technicality, which is they're saying somehow if I fix the spring to a surface, that I fundamentally change how the spring functions. All right. So so that's the point we're at. And it does seem, there is an awful lot in terms of what physics could possibly mean to you in having to concede that this formula is wrong. I can understand. It's 300 years old. You've had millions of scientists and they've all just stepped over the bullshit of it and never really thought about it and never thought of the implications of it. And they've just accepted it because, well, all the other people accept it, so I'll accept it. And they never really scrutinized it or paid any attention to what they were accepting. And that's a pretty bad. That's like having, it's like having a 100-year-old chicken head on one of your dinosaurs in the museum. It's really lame. It's a huge failure in the science. And that's a lot to concede, I understand, but that is the truth. And, you can do the little tiny bit of investigating and see it for yourself. You just go look at the Leibniz, go look at the kinetic energy versus momentum debate, and it becomes, you can't read all that nonsense and not realize that this wasn't good science. That this idea wasn't proposed by compiling a great volume of evidence to prove it. It was just proven by people's aggressive desire to believe in it. And it really didn't have anything to do with science or doing good science. And that's a lot to concede, because now a lot of things in your science become suspect. I understand your paranoia, that you can't admit that, oh, science could make such a fundamental error and all the scientists could be too stupid to figure something this simple out. But clearly that's the truth. I'm sorry to inform you, but you can't evade the facts. The fact is, it was silly 300 years ago. It was silly, 257 years ago. It was silly 100 years ago. It's always been silly. It's always been nonsensical. And it's been obviously so. The paradoxes have been right in front of your face. I mean, you've been saying things that don't make any sense. I mean, physics girl sat there and said, I 100% transferred the momentum, yet I lost half the energy. I mean, it's such an offense to everything Newton ever talked about. I mean, that should just make them unsettled right from the start. What would Newton say to that? You just lost half the energy? What do you mean you lost half the energy? How did you do that? Where did it go? Because nothing exploded, nothing got hot, nothing did anything to indicate there was energy going in any other direction. So where did it all go? Anyway, I've already made these arguments over and over again. So, so we'll leave it at that. There isn't much else, and there hasn't been any evolution in the counter argument. So that's where we're at currently. And like I said, if worst comes to worst, I'll do the experiment. But yeah, I'd rather somebody do it well. But anyway, I mean, whatever. It just seems crazy that it's not out there already. That nobody's ever put two different weight objects on a spring and videotaped it. It really is surprising. All right, till the next time and such and so forth and whatnot.